Hey, what's going on, guys? It's Bell here. I record stuff on YouTube, chat description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it, and this is called delete columns to make sorted tree. We are given an array A of n lowercase letter strings, all of the same length. Now, we might choose any set of deletion indices, and for each string we delete all the characters in those indices. For example, if we have an array A which got those strings right there and deletion indices 0, 1, 4, then the final array after deletions is BC, A, Z. Suppose we choose a set of deletion indices D such that after deletions the final array has every element row in lexicographic order. For clarity, a 0 is an lexicographic order, means that an element at the position of 0, 0 in A is less than or equal to 0, 1 is less than or equal to 0, and this right here means the length of the string at the position of 0 in A minus 1, you know, the 0 based A at the position of 1 is in lexicographic order. A 0, 1 is less than or equal to 1, 1 is less than or equal to 1 and 1 dot length minus 1, and so on. Return the minimum possible value of the dot length. Let's look at those examples right here. We got those strings, we return 3 after deleting columns 0, 1 and 4. The final array is BCAZ. Both these rows are individually in lexicographic order. 0, 0 is less than or equal to 0, 1, and 1, 0 is less than or equal to 1, 1. Note that an element at the position of 0 is greater than the element at the position of 1. The array A is not necessarily in lexicographic order. Right here, if we delete less than 4 columns, the only row won't be lexicographically sorted. All rows are already lexicographically sorted. The length of the array and the length of the string at the position of I in A are greater than or equal to 1 and are less than or equal to 100. Well, we can solve this problem using dynamic programming. We can solve this problem using tabulation methods, bottom-up approach. I'll show you how to do that. We maintain an array and we do all calculations based on the first value, and when we talk about dynamic programming we think about the very last step. We will return the minimum possible value of the dot length. Go for it. We create a few variables. The first one m, which is the length of the array, n, which is the length of the string at the position of 0. You know, you could notice from the description of this problem that those strings of the same length. Then the result is equal to n minus 1. We need to maintain an array, as I said before. Array, the type integer. The length of that array is equal to n, and we need k variable as well. Then we fill that array with ones, 1, and initially by default we got a bunch of zeros. After that method we will have 1 1 1 1 bunch of ones. Then we create a for loop int I, which is 0, I is less than n, the length of the string I plus plus. Another for loop, which is nested for loop. We start from 0, j is less than I, j plus plus, and here we initialize k. We set up to 0, k is less than the number of strings m, k plus plus. At each iteration we check. In the case when the character at the position of j in case position the string case position in a is greater than the character at the position of I into the string which is at the position of k in a, we break out of that loop in the case when k is equal to m, the number of strings, and the value at the position of j. We can transform this. We transform this problem to find the maximum increase in subsequence. Right here we are finding the maximum increase in subsequence, and in the case when the value at the position of j in array plus 1 is greater than the value at the position of I, we update the value at the position of I to array j plus 1, and result we trying pick up the minimum value. We use min method, and in the case when the value n minus the value at the position of I in array is less than the previous result, then we update the result. If it's not, then we do nothing, we just leave the result as it is. And finally return the result. That's it. We got those variables m, n. The result, we maintain an array as I said before. We fill that array with ones, then we create 3 for loops, and we each iteration trying to we are finding the maximum increase in subsequence right here, and then we update the result. Yeah, let's run this code. Accepted, good. Let's submit. Great, success. The time complexity for this problem is big of m, the base n raised to the power of 2 big of m for comparing elements, uh, the base n raised to the power of 2 for finding the maximum increase in subsequence. Overall, as I said, a big of m multiplied by the base n raised to the power of 2. The space, we use an array right here. I would say, we can say it is like in the linear time, but I would say it is close to the constant time, because we got a predefined size of this array that's like, linear, close to the constant time. Right here we got I, we looping until n, the length of the string, and we, at each iteration we increment j, we up to I, we go to the middle, for example, just right here and right here we are, or just for example, I, this is I and this is j, right? So we are here. Okay, yeah, this is j and this is I. So j, we are here, then we increment j by 1. We are here, 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 here. K means that we choose the string at the position of k, like, like the first one, or just the second one, and j means that we pick up the character at the position of j to your left, for example, like b, right, and I to your right, a, b, a, or just for example I is equal to c, right, and j is equal to 0, so we increment j by 1, we compare b and c, right, then a and c, then b and c, right, then we break out of that loop, we check right here, we update the result, and so on. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. Follow me on Instagram. Add me on Snapchat. I do all LeetCode problems. Yeah. If you need some help, leave your comments below. I think I explained it pretty good. That's nothing difficult. That's pretty obvious what we are doing here. Just quadratic time solution, finding the maximum subsequence, increasing subsequence, and get the result. Yeah. Thank you guys. I'll see you next time. Have a good one. Bye.